Hello and welcome to IGCSE Mathematics 0580 extended course, syllabus topic E1 number, module 1.2. It's about sets. In this video, we'll be talking about exercise 2 of set number 8, and it's a part 4. And as you know, we are referring to this book, Complete Mathematics for Cambridge IGCSE extended course, written by David Rayner. Okay, so let's start exercise 2 of chapter number 8. In question number 1, we are given two sets. M is equals to 1, 2, 3, 4, 5, 6, 7, 8, and N equals to 5, 7, 9, 11, 13. And in the A part, it says M intersection N. Intersection means common, right? So we just have to look at the members of M and N, and we have to pick off from these both two the common in between. So it means that you can see 5 is there and 5 is there as well. So 5 is one of the intersection, and 7 is there, 7 is there. There are only two members which are common in M and N. So M intersection N equals to 5 and 7. In part B, it says union. As we know, union means combine. We have to combine the elements or members of M and N without repeating the element. It means that it will come, I mean, if you look closely, M is starting from 1 to 8 and N is 5, 7, 9, 11, 13. It means that 1 to 8 will come as it is till here, 1 to 8, and then of course 5 and 7 we already covered, so only members are left are 9, 11, 13, and we write these three members as it is. So this is the union of M and N. In part C, it says number of elements of N. We know that this small n represent the number of elements or number of members of set N. So if you count the number of elements or members of this set N is 1, 2, 3, 4, 5. So 5 is the answer. In part D, it says number of elements of M union N. So first of all, we just need to know M union N. We have already evaluated in part B, which is this one, and it says number of elements. So you just need to count these elements. It's 1 to 9, so 9, and then 10 and 11. So there are 11 members or elements of set M union N. In part E, it says we just need to answer true or false. It says 5 belong to N. So it means that we have to look at in the members of M, and 5 is there. It means it is true. And in the F part, it says 7 belongs to M union N. So we need to look at the set of M union N, and 7 we have to check either 7 is there. Yes, 7 is there. It means it is true as well. In part G, it says we have to check N is the proper subset of M. So in order to check whether a set is a proper subset of another set, we just need to look for two things. First thing is that either the members of the left side set are in the right side set. First thing. Second is that the right side set must be greater than that of left hand set. So let's see the first check to check the members of N. So if you look at the members here, it got 5, 7, 9, 11, 13. So we have to see either they are in M. So only 5 and 7 are there and rest of the members not there. So straight away it is not possible at all. So it means that this is not true. So this is a false statement. Now let's see in the H part. It says 5, 6, 7. It's a set. We have to check either true or false. Is the proper subset of M? So first check, we have to look at 5, 6, 7. Are they in M? So we have to check the members in M. 5, 6, 7. Look, 5, 6, 7 are there. So first check is passed. Second check, we have to see either M is greater than 5, 6, 7. And of course M is greater than, because it got 1, 2, 3, 4 and 8 which aren't there. It means that this is a proper subset of M. So this statement is true. In question number 2, we are given two sets. A equals to 2, 3, 5, 7. B equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So in A part, it says A intersection B. We know the meaning of this intersection mean common. So we need to look the common in between these two sets A and B. So what else common? 2 is there, 2 is there. So 2 is the first intersection. 3 is there, 3 is there. So 3 is the second intersection. and 5 is there, 5 there is as well, because detached mean you can just just think of the number, it is 3 to 9, so including all integers. So of course 5 will be there as well, and then 7 as well. So this is the intersection of A and B. Then in B part we have to calculate the union, mean we have to combine the sets elements of set A and B, provided no element should be repeated. So we can see that it will start from 1 2 3 all the way till 9. 1 2 3 4 all the way till 9, because of course once you written that, these members are automatically included in that, that is 2 3 5 7 are all included in the union. In part C, we have to calculate or find out the number of elements of A intersection B. So we have to look in that set. How many elements it got? 1, 2, 3, 4. So 4 is the answer. In part D, we are given a set 1 and 4 and intersection with the A. So we have to find out the common between 1 and 4 and set A. So we can see that 1 and 4 aren't there at all. It means that the answer is the empty set or null set. In part E, we have to state it either true or false. It says A belongs to B. Always remember, we have already discussed this particular sign belongs to only work for the element or the member. It doesn't work from set to set. So this statement is wrong. It means it's a false statement. In part F, it says A is the proper subset of B. So first, as you know, there are two checks for proper subset. First of all, we'll look for the elements of A, either they are in B or not. So in A, we got 2 3 5 7, and of course you can see that 2 3 5 7 are there. Second check is that B must be greater than A, and we can see that 8 and 9 are there, which aren't in A. It means that this is a right statement. A is the proper subset of B. In part G says 9 is the proper subset of B. Now guys, this is one very important point. This statement proper subset only work from set to set. On both sides of this symbol we should have set, not number or element. It means this is a wrong statement or it is a false statement. In part 8 it says 3 belongs to the set A intersection B. So we have to look into A intersection B, which is this set, and look, 3 is there. It means this is a right statement or this statement is true. Question number 3 is almost similar to question number 2. So we're doing question number 4, part D. Part A, B and C are absolutely like the previous one. So even if you do the part D, E, F and onward, you will understand part ABC. So in part D, we have to calculate D union of E and then intersection of F. In mathematics, we always solve the brackets first. So it means that we need to find out the D union E first, and then whatever the answer will come, we'll take the intersection with the F. So first we find out the D union E. In union, we need to combine the elements of D and E together without repeating any of the element. So it means if you combine 1 3 5 and 3 4 5, it will be 1 3 4 and 5, right? And now if you take the intersection of this set with the F, it means the common between these two. So the common will be, right, so the common will be only 1 and 5, because 10 is not there. So it means that this is the answer of this part D. In part E, it says you have to find D intersection of E first, because this is in the brackets, and then whatever the answer, you will take the union with the F. So let's find out first D intersection E. Now it means that you have to take the common of these elements and the E with these elements. So the common is clearly 3 and 5, right? So answer will be 3 and 5. And then you have to, what you do, we have to take this set union of this set. It means this set and this set you have to write with the combine. You have to combine 3 and 5 and 1 5 10. So the answer will be 1 3 5 and 10. In part F, it says you have to find out the number of elements of the set D union F. So first of all, let's find out what is D union F. It means that you have to take the combined set of D and F. So it is D is 135, F is 1510. So if you combine them two, it will be 1, 3, 5 and 10. Now it says the number of elements of this set. So how many elements it got? It got 4 elements. In part D it says we have to tell it either it is true or false. D is the proper set of E union F. So as we know, we have to solve this bracket first. So let's find out E union F. E is 3, 4, 5, F is 1, 5, 10. So union mean you have to combine the elements of E and F without repeating. So it will be 1, 3, 4, 5 and 10. Now this is E union F. Now you have to check either D, which is 135, is the subset of EUF, which is 1, 3, 4, 5, 10 is not. So the first check for the subset is we have to check the elements are the all elements of this left hand side set are present in the right hand side set. 135 is there. So first test is passed. Second test, the right hand side should be greater than the left hand side. So of course it is greater than D. So it means that this is a true statement. D is a subset of E union F. In part 8 it says 3 belongs to E intersection F. So first we'll find out the E intersection F. So it means that we have to take the common of set 3, 4, 5 and 1, 5, 10, and the common of these two sets is only 5. Now we have to see 3 belongs to 5. Of course not. So it's a false statement. In part I it says 4 does not belong to, because it's a cross on belong to sign. 4 does not belong to D intersection E. So we find out D intersection E, which is 3 and 5, and 4 does not belong to because there is no 4 in this set. It means this is a true statement. Okay, so in the next video we'll continue to solve exercise 2 of chapter number 8 from question number 5 to 6. So see you there.